Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. So today we have to solve a problem in which we have to design the control circuit for a vending machine, which has the following specifications. Before solving any problem, we must understand the requirements of the problem carefully. So the requirements are: when the machine has received 15 cents, it delivers a package of candy. If too much money has been added, the machine returns the difference. When the candy has been released, the release mechanism brings the circuit back to the original starting state. So, this is the requirement of the problem. In the first requirement, we have to design the machine in this way that if I entered 15 cents, the machine gives back a packet of candy. If more than 15 cents been added to the machine, then it should be returned the change with a packet of candy. And when this operation has been done, the machine must return to its original state, initial state. So, and one more requirement is that the machine accepts nickels and dimes. So nickel is a type of currency which consists of 5 cents, and dime consists of 10 cents. Both of the currencies are used in US. So like for the machine to deliver a candy, one must has to enter one nickel and one dime or three nickels. So then the machine will deliver a packet of candy. So these are the requirements of the problem. Now I have solved this problem. Let me show you. So this here is the block diagram for the machine, and then the condition for the machines are given as like if z is equal to 0, no change has been returned, but if z is equal to 1, you can use any variable. I have used z for the change and y for the candy. Then there are state diagrams, but let us discuss these conditions. So when z0, no change been returned, but the candy will be returned. But if z is equal to 1, change return of 5 cents. Why 5 cents? Like we can enter in multiples of 5, as nickel consists of 5 cents and dime consists of 10 cents. So if we entered 4 nickels, or 1 dime and 2 nickels, in this way we entered 20 cents. So 15 cents for the candy and remaining cents will be returned to us as change. So here I use this condition. Then there is state diagram. I have solved this problem using Bay machine. So according to the state diagram, uh, when no amount of money has been entered, then we have S0 condition, then as S1, like if we enter 5 cents, then S2 we enter 10 cents. So at this stage, no candy or change will be returned. But for S2, if we entered 20 cents, one candy and one change of 5 cents being returned. Similarly, if we entered 15 cents, then no change but a candy pack will be returned by the machine. Then I have drawn this truth table for the states of the machine. using S0, S1 and S2, S0B00, S1B01 and S2B10. And by using these logics, I have drawn K-map, and then I solve the K-map for the desired equations like dA, dB, y and z. As discussed earlier, Z for change and Y for can you. So by using these equations, I implement this logic on Proteus, like when D0 and 0 you have entered no amount of money, then no change will be returned back by the machine and no candy will be entered out of the machine. Then when D1 and 0, then Y is 1. It means that when D is 1, then the candy will be returned out of the machine. So in this way I have drawn this table and implement the logic by using Proteus. So then I use the logic analyzer in Proteus to verify and implement these equations. So let me show you. So first here it is, it represents that the change is returned, but let me show you the first way. So this, it represents the candy is returned by the machine, and then here it is, this part of wave represents that both candy and change are given out of the machine, but when only this part represents the change is returned by the machine. So first part represents candy, second part represents the change returned, third this wave represents that both candy and change are returned by the machine. Then we have this wave which represents that you have entered 5 cents, so no candy or change being returned by the machine. Okay, so after that, after these equations verification using logic analyzer in Proteus, so we have seen that the change returned by the machine first represents, this wave represents that the machine returns candy. This represents that change is returned by the machine. This represents both change and candy returned by the machine, and this wave represents that someone entered less than 5 cents or less than the cents as the amount of the candy, so no candy or change is returned by the machine. And then here it is D and both are operating at opposite logics, like one is high, other is low. When other is low, then this is high. So in this way I draw the vending machine circuit on Proteus and design it. So this is all about the question 5.5, the vending machine. Thank you.